Bismillahirrahmanirrahim. I am Riaz Hussain Junaidjo and I am delivering the video lectures for the course of Applied Electricity and Electronics. This course is being offered by the Department of Electrical and Computer Engineering, Kamsat University, Islamabad, WA campus for the semester of fall 2020. This course is being offered for the program of Civil Engineering semester 1. This is a series of lectures and today we are going to study lecture number 3 and today's topic is voltage, power and energy. Again, for the information of the student that these lectures slides and video lectures are being prepared from the textbook of the author Alexander Sadiko. So let's start. Previously we defined charge and we also define voltage. So now we are going to study voltage. So how we can define a voltage? We know that if a charge is held at a specific position and if we want to move that charge from one point to another point, then the work must be done in moving that charge from one point to another point. So this work is performed by an external electromotive force and we call such force as an EMF force such as battery. The sole purpose of battery is to move the electric charges from one point to another point. And this EMF or electromotive force is also known as voltage or potential difference. There are different terminologies associated to that force. We simply call it voltage or potential difference or simply potential. And the voltage VAB, that is potential difference between point A and B, is the energy needed to move a charge from point A to B. That is, let's suppose we have 2 points in circuit, point A and point B, and if we want to move a charge from this point to this points, and then obviously we cannot do that without any expense of energy. So that energy needed in moving this certain charge from point A to point B is known as potential difference or voltage between points A and B. And mathematically we define that VAB is equal dW divided by dQ, where dW is the rate of change of work or rate of change of energy and dQ is the rate of change in the charges. So you can see that potential difference or voltage between 2 points is the work done moving one charge from point A to point B. So starting point is point A and final point is or terminal point is point B. Voltage is measured in volts and obviously its unit can be joules per coulomb. You can see that volt is not a basic unit or fundamental unit, it is drive unit. 1 volt is defined as 1 joules per coulomb, that is 1 Newton meter per coulomb. And voltage is measured by an instrument that is known as voltmeter. Generally we have a single instrument and we call such an instrument multimeter. So we have to select the voltage range and then we can find the measure the voltage across the two terminals A and B. Yeah, again remember that to measure the voltage between 2 points A and B, you have to connect the voltmeter across the terminals A and B. So let's say we want to measure the voltage across and this element, so we have to connect voltmeter at point A and point B. So this is the across connection along this device. So VAB can be interpreted as point A is at a potential VAB volts higher than the potential at point B. So we can say that if we have voltage in between 2 points 5 volts, so this means that point A is 5 volts higher potential than the point B, or the potential at point A with respect to point B is VAB. Obviously it shows that VAB is equal to minus VBA. That is, if we reverse the polarities or points, then voltage will be negative. Like electric current, a constant voltage is called a DC voltage and it is denoted by capital V, while a varying voltage is called in AC voltage, and it is denoted by small v or v of t. So in this case, AC voltage is changing with respect to time, but DC or voltage or constant voltage, it is fixed, it does not change with respect to time. And one more thing, that voltage or potential difference is an scalar quantity. It does not have any direction in space, but voltage can be positive, voltage can be negative, and or potential can be zero. If potential between 2 points is zero, it means that the points are at the same potential. So in that case, difference of the potentials will be zero. If point A is at larger potential than point B, then VAB will be positive. If point B is at higher potential than point A, then VAB will be negative. So we can say that, let's suppose we have point A and point B in between, then voltage is 9 volt, and this is same as if we if we reverse the polarities or points, then this is negative point, now this is positive point, and then we have suppose that applied minus volt, so still potential difference between point A and B will be 9 volt. So next we'll define power and energy. Already we know that what is the power. Power is the time rate of expending or absorbing the energy. There it is measured in watts. This is the SI unit of the power, and in electrical engineering we also use the same unit, that is watt. So mathematically we have power is work done per unit time, and if we multiply and divide with dq, so we can see that this equation can be written as dw by dq multiplied by dq divided by dt. And now we can identify that dw divided by dq is actually, just like we mentioned, this is voltage, so we can say that this is voltage multiplied by dq divided by t. Obviously this is rate of change of charges with respect time, and we say that this is actually current. So we can say that electrical power P is equal voltage multiplied by I. So this means that if you want to calculate the power absorbed or provided by a certain element, we simply measure the voltage and current flowing through that element, and then we multiply these two quantities and can get power. So you can see that power can be actually again, power can be positive or power can be negative or power can be zero. Power is still a scalar quantity. The power in equation 3 is called instantaneous power. That is power in this case, because current and voltage could be changing quantities, so power is also changing. So in that case we say that power is instantaneous in this case. If a power has a positive sign, power is being delivered to or absorbed by the element. Suppose we have an element in the circuit and its power turns out to be positive, so it means that that element is absorbing the power. If power has a negative sign, power is being supplied by the element. So this is again the case of the battery. Obviously battery supplies the power, so generally mathematically you say that power supplied by the that element is negative. Passive sign convention, again we generally use passive sign convention. In that case, current enters through the positive polarity of the voltage, hence P is equal plus VY. If the current enters through a negative terminal, then P is equal minus VI. Remember that in circuit analysis we'll be using the passive sign convention, that is current enters through the positive polarity of the source. And then we can define in electrical energy. We know that energy is the capacity to do work. So we can say that electric power utility companies measure energy in kilowatt hours, that is kWh, where 1 watt hour is 3600 joules. Obviously from this equation we can also find the energy. So energy will be equal power multiplied by time. So we can say that energy is how much power consumes throughout certain time interval. So electric power utility companies measure that power in a certain period. Generally that period is month. So how much power you have consumed in 1 month. So using that number, they calculate the number of units. So generally 1 unit is 1 kWh. So let's see some examples related to potential difference, energy and power. So an energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kilojoules of energy is given off in the form of light and heat energy, calculate the voltage drop across the bulb. So we are given a current that flows through the bulb and current is 2 ampere. So let's suppose that current flows for 10 seconds, and in that 10 seconds the energy that is given off in the by the bulb is 2.3 kilojoules, and we want to find the voltage drops. So we know that total charge transferred obviously in this case will be delta Q is equal to I multiplied by delta T. Since we know that I is delta Q divided by delta T, so we can find that delta Q will be equal to 20 coulombs. Now voltage drop, we know that voltage is dw by dq. So in that case we can use the value of energy in this case is this is 2.4 into 10 power 3 joules divided by charge is 20. So in this case this will be 2.3 into 10 power 3 divided by 20. So we can easily find that in this case V is equal to 115 volts. So this is the voltage drop across the bulb in those 10 seconds. So you can see that for finding a certain quantity, we have to first calculate the quantities then which are required in the formula. You can see that formula for V is equal to delta W divided by delta Q, or dW divided by dQ. In this equation, since we don't know dQ, we are given the energy or work, but we have to find the delta Q. So we have to use the value suitable formula for finding delta Q. So we can see that delta Q can be computed using current and time. Let's see another example. To move a charge Q from point B to point A requires 25 joules of the work or energy. Find the voltage drop VAB, the voltage A at A with respect to point B. If A is equal to 5, if A is equal, in fact Q is equal to 5 coulomb, and Q is equal to minus 10 coulombs. So we have two different charges. So let's suppose we transfer those charges from point A to point B, and we consume or provide the energy that is 25 joules. So we want to find the voltage drop. So we know that V is equal delta W divided by delta Q. So in that case, for problem part A, we can say that this will be 25 divided by Q is 5. So 25 divided by 5 will be 5 volts. So for B, we can see that for B part of the problem, Q is equal minus 10 coulombs. So in this case, V is equal delta W. So delta W is still same, 25 divided by in this case delta Q is equal to minus 10. So 25 divided by minus 10 will be minus 2.5 volts. So we can easily find the voltage in each case. Let's see another example. Find the power delivered to an element at time t is equal to 3 milliseconds if the current entering its positive terminal is I is equal to 5 cos 50 pi t amperes, and the voltage is V is equal to 3I. So let's see the solution. Since we want to find the power delivered to the element at a specific time, then that is time t is equal to 3 milliseconds. If the current, so current we are given the current I is equal to 5 cos 50 pi t, and voltage is also given, that is V is equal to 3I, that is 3I, and value of I is this. So we know that P is equal to VI. So in this case P will be equal to V. So V is equal to 3I, 3 multiplied by value of I is 5 cos 50 pi t, and multiply by I. So I value of I is 5 cos 50 pi t. So we have to simply plug the values. So we can easily simplify. This will be 3 into 5, 15 into 5, 75. cos into cos square, this is 50 pi t watts. Okay? So since we want to find the power delivered at time t is equal to 3 milliseconds, so we have to plug value of t, that is 3 millisecond. Means 10 power minus 3. So at time t is equal to 3 millisecond, power will be p is equal to 75 cos square 50 pi into 3 into 10 power minus 3. We can easily evaluate this using calculator. So this is 53.48 watts. So power that is being delivered to the element at time t is equal to 3 millisecond is roughly 53 watts. So let's see another example. How much energy does a 100-watt electric bulb consumes in 2 hours? So we have a bulb that its power rating is 100 watt. We want to find that how much energy it will consume in 2 hours or 120 minutes. So we know that work or energy is equal to power multiplied by time. So in this case we are given the power. So this will be 100 multiplied by time. Remember to find the energy in joules, we have to convert this time in hours into seconds. So this will be 100 into 2 hours. So 2 hours actually 2 into 60 into 60 seconds. So we can see that this is 720 kilojoules. So we can convert this energy into conversion commercial units. So remember that power energy in kilowatt hour is actually 1 unit. So in this case work energy here is p into time t. So p is 100 watt multiplied by 2 hours. This is 200 watt hours. So you can see that actually 100 watt bulb will consume 0.2 units of the energy in 2 hours. Let's see another example. A home electric heater draws a current of 10 ampere when connected to a 115-volt outlet. How much energy is consumed by the heater over a period of 6 hours? So we have a heater and it draws a current of 10 ampere when it is connected to voltage of 115 volts. So we want to find the energy consumed, and we know that energy is equal to power into time. So this is equal to VI into T, because power is voltage multiplied by current. Actually electrical power is VI into in fact P is equal to VI. So we can easily substitute the values for V, because V is 115, I is 10, and T, because T is 6 hours. So we have to convert those 6 hours into seconds. So this will be 6 into 60 into 60. So we can see that this is 2.4 into 10 power 7 joules. So if we want to convert that energy into commercial units, that is into kilowatt hours, simply we have to divide with number of seconds. So energy consumed in kilowatt hour will be and this energy, this because divided by 60 into 60. So this is 6.9 kilowatt hour. So actually that heater if operated by for 6 hours will consume 6.9 number of units. So thank you so much. This was about the basic terms about electricity and that is power and energy. Next we'll see some more topics. Thank you so much.